हुआ बे? अबे रॉकेट काहे बने हुए हो?
ग्रेजुएशन के लिए सिर्फ 4 महीने बचे हैं और समझ नहीं आ रहा आगे क्या करूं। शुरू कहां से करूं?
अबे इंटर्नशाला ट्रेनिंग से मैं बताता हूँ। यहाँ है मशीन लर्निंग, जावा, एचआर, टैली जैसे बहुत सारे करियर बिल्डिंग ट्रेनिंग सेलेक्ट कर और अपना करियर शुरू कर। इंटर्नशाला ट्रेनिंग्स, शुरुआत यहीं से।
Hello and good evening, everyone. I'm your host Manpreet Arora. Welcome to the 7th season of IST Practicals by Internshala Trainings. IST Practicals is a series of free online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST practical is an opportunity to experience the power of practical learning. In the first episode of this season, we have Phil taking a session on Matlab. He has over 5 years of experience teaching Matlab and other programming languages and has taught more than 16,000 students both online and offline. I hope you will enjoy this webinar with him. We have a very special gift for you at the end. तो चलिए करते हैं मैटलैब सीखने की शुरुआत यहीं से and let's welcome Phil.
Good morning, everyone. Thank you so much for having me. I know you guys are all around the world today. I'm from the USA, so greetings wherever you are in the world. For those viewers from India, hope your evening's going well and a happy belated Diwali. As Manpreet said, my name is Phillip Parisi. I learned Matlab first 8 years ago now, and I've really enjoyed having the opportunity to teach different students like yourself about the language, and we have a very exciting presentation today. I want to start things off with a quick poll question for the audience. Put your answer in the chat. What does the word Matlab actually stand for? Put your answers in the chat. I want to hear what you guys think. And as a hint, it is short for 2 words. So Matlab is actually an abbreviation for 2 words. Go ahead and put your answers in the chat of this live stream. Here we go. I'm seeing some people having the right question. Good answers right here. Yep, everyone, you are absolutely correct. Matlab is short for Matrix Laboratory. And that's because the original developers of the language needed something to handle really large matrix calculations, and they built an entire language out from that. Here's our second quick poll question. Which industries utilize Matlab the most? Put your answers in the chat. You got about 20 seconds, and then we'll come back and review. Which industries utilize Matlab the most? There's no wrong answers here. I'm seeing engineering. Amit said graphic. We've got data from Harsh. NASA from Mahadevan. Hope you're doing well, Mahadevan. Good to see you. AI, machine learning, database. Exactly. So in general, you can use Matlab as a multi-purpose language. It's seen most often in the industries of science, technology, engineering, and mathematics, the STEM fields, but you can use it anywhere that there's data you need to process, or images you need to visualize, or data you need to visualize. It's got many applications, and we'll talk through those today. Here's the agenda that we have in store for you. I'm going to open up by talking about programming languages as a whole, and we'll understand where Matlab fits in amongst the hundreds of languages that exist. Then we'll cover Matlab's specific advantage. Why would you bother learning it when there's 99 other languages out there? And what makes Matlab special? Then we're going to talk about some key principles and the fundamentals of the programming language. We'll talk about data types, logic, and cover loops. And then I'm going to show you 4 different projects and examples, things from machine learning to making scatter plots to even a fun little tank game that I've put together that has animated action in it. So stay tuned for sure to the end of this presentation. Let's talk big picture and discuss what even is programming. In short, It's telling your computer what to do. You can provide it a set of instructions, which we call scripts, to be executed by your computer. Really quick, if you have a second, open up a new tab in your browser and then click Control and U at the same time. This is going to show you the code, the HTML code that makes up your graphics that you're seeing on the screen. It's a quick, fun way to see what's happening behind the scenes and understand that code is what makes up everything in our digital world, from graphics to the very base level hardware that runs our processors. You'll see programming languages used for a variety of applications. Matlab covers most of these. You have some programmers developed and dedicated to apps and web development. You can make games with them. All of the Xbox games that we have are all built in some programming language. Data science is extremely popular these days, and even robotics and AI has seen a lot more attention with development of faster programming packages and as computing power has increased over the years. Matlab's main core is in numerical computing. As we talked about, it is the matrix laboratory, and it is ideal for doing hard, continuous calculations on matrices. And of course, embedded systems like Raspberry Pis, Arduinos, and microcontrollers can even be interfaced with Matlab. On the right, notice this hierarchy I've formed of different types of languages. These may be unfamiliar to you, but we have two sections. The high-level languages are the interpreted languages and the compiled languages. As you get into low-level languages, we're talking about things like assembly, machine languages, and hardware. You've probably only heard about interpreted and compiled languages because that's the only thing that we as humans can understand. It uses real words that we can code. If you get down into machine language, you're talking about the zeros and ones that make up the very base units, bit by bit, that our computers run. We don't like to work in low-level languages because you'd only be typing zeros and ones all day long. We work in high-level languages because we can understand them. Here's a couple examples you may be familiar with. Matlab, Python, and Java are very common interpreted languages. C++, C, and Fortran are compiled languages. And we'll get into the more differences and nuances in just a second. So at the top, we have the high-level languages, and at the bottom, the lowest level languages. This is a scale, and there's a couple other variables we should talk about to understand the differences. At the very top, the interpreted language tend to be the slowest languages. And as you get down to the hardware, those languages are the absolute fastest. However, slow is fairly relative. A MATLAB program can still run in 1/10 of a second, right? So the scale is very different. But the most important part is how readable these languages are. It might be the fastest to program in binary with machine language, but it's absolute nonsense to anyone who looks at it because humans don't think in zeros and ones. Thus, as you go up this hierarchy, the languages become more readable, which is why humans work in the high-level interpreted and compiled languages. Thus, you could say that MATLAB is a high-level language that is easy to read and thus learn. However, it can sometimes be slow. To visualize this speed versus learning versus readability, give and take, let's take a look at this visual. In MATLAB, if you want to write a program, let's say it takes you about a week. And then when you run the code, you're churning through a lot of data, so it takes you about 15 seconds to actually run that code and get an answer out from your computer. If you wanted to write the same program in C++, it might take you 2 months to program this. However, you do have the benefit that the program will only take about 1 second to run. So you can see the program runtime is now 15 times faster, but your actual development time to learn the nuances of C++, make sure you get all the right libraries included, there's other overhead that goes into the language, you're going to increase your developing time. And lastly, if you're really interested in learning binary, this might take you over a year to write the same program we wrote before. But the benefit, you have that shorter runtime again, only about 0.2 seconds to run the program. So you can see now with Matlab as an interpreted language, a little bit longer to run, but your overall development time is much shorter. Whereas when you get down to binary, one of those low hardware assembly languages, a lot longer time is needed to code that, but a little bit of benefit with the runtime. I hope this visual helps you to understand the give and takes of that hierarchy of various programming languages. A few more notes about Matlab in general. The first thing is that it requires a license from mathworks.com, the company that owns the language. This needs to be purchased, or more likely than not, your educational institution or the company you work for will actually provide you with a license so you don't have to pay anything. Matlab also is one of the few programming languages to come with built-in support. You can ask them for questions. They have a team willing to help you. Matlab also comes with tons of built-in packages. So right out of the box, you have a lot of capabilities and functions that you can utilize for your different programs. And if you need extra features, you can download those and add them to your Matlab installation. Typical programming languages will call these packages, and Matlab calls them toolboxes. Here's going to be a quiz question today. What are Matlab's advantages? I'm going to pull up the Internshala Trainings here. This is the website that they use for all of their online trainings. Here's the question. What are Matlab's advantages? Go ahead in the chat. Is it going to be answer A, it's easy to read and learn, B, a short time spent writing code, C, fast code execution, or D, many built-in capabilities? And as a hint for you, there are many answers to this question, so feel free to select multiple choices here. Put your answers in the live stream, and I'll give you about 30 seconds to do this. Again, multiple answers are correct here. All right, I'm seeing some good answers coming in right now. Keep it up. I want to hear from a few more of you. What are Matlab's advantages? Is it easy to read and learn? Is it a short time spent writing code, fast code execution, or many built-in capabilities? What do you think? Put your answer in the live stream chat. Turns out there's 3 answers to this question, A, B, and D. Perfect. There we go. And we'll cover the next question in a little bit. Now we're going to shift into programming principles. Some of the basics that exist in actually most languages, and we're going to cover them with the Matlab syntax today. Basically, how would you do this in the Matlab language? We're going to start with data types. Data types are how computers store information in memory. Naturally, you could imagine that storing the number 1,091,700 and something would require more memory than just storing the value of 5. There's more information to the 1 million number, right? It even takes us longer to write it down. It takes up more space on a piece of paper. Our computers need more space to store that information. In general, we aim to be efficient with our memory. And different types of data types will enable different operations on those values. you can add two numbers together very easily. But if you store two strings like my name of Phil and our host name of Manpreet, you can't really add those together the same way that you add integers together. The data types allow for different operations on each other. We're going to start with numerical data types. An integer stores positive and negative whole numbers. Numbers like 7 and 1009 are examples of integers. A float, also known as a double in Matlab, stores decimal values. Things like negative 0.1234, the value of pi, 3.14159, and continuing. When you need to store decimal values, you use doubles. Here is how Matlab would store these variables. It uses the equal sign to assign a given value to a variable name. So here I'm assigning the value of 5 to the variable x, and also the float type of 0.998, that value to y. Matlab takes care of assigning the specific data type needed. However, in other programming languages like C++, you need to specify the data type that you're assigning a variable. Again, in Matlab, it takes care of this for us. We don't have to worry about whether it's an int or a double. It takes care of this for us. But for example, C++, you need to include the data type when you declare the variable. Moving on to text-based data types. A char, which is short for character, stores text characters, things like the letter W or an exclamation point. And then once you start putting strings of characters together, you can then store words and phrases, things like hello world or I love Matlab, right? Longer phrases should be strings, and individual characters or a few characters side by side should be stored as a char. The last type we're going to cover today are logic. Logic data types are very different, and we call them Booleans. And this is because they can only store one of two values, which is a 0 or a 1. We call these the logical zeros and logical ones. For example, true. The word true and 1 are equivalent in Matlab. True means 1, whether it's a capital T or a lowercase t. These words are interchangeable. You might have seen this type of stuff on a switch, maybe a light switch in your house or the switch to a fan, where you see the 0 and a 1. Look around your house. I bet you've got this type of switch in there. When it's on 1, the device is going to be on. So your fan is switched to 1, your fan is blowing air. If, however, you switch it to 0, it moves to false, which means that the fan is off. Keep your eye on your house. I bet you'll find these switches. These are the Booleans, the zeros and the ones that we see in programming languages. Now we're going to move into the examples of logic and conditional statements. Let's define a few variables. X has a value of 10 and Y has a value of 7. I'm going to ask you the question, is X greater than Y? This is a simple comparison. Of course, we just compare the values of each variable. And we ask, is 10 greater than 7? Well, clearly, the answer to that is yes. That's true. But remember, computers only like to talk in true or false, the zeros and the ones. So we'd say that, is X greater than Y? True. A few others here. Is X less than Y? Basically, is 10 less than 7? No, that's false. Is X equal to Y? We use the double equal sign for checking equality between two variables. That's false because 10 is not equal to 7. And does X not equal Y? That's true. A little squiggle called a tilde means not. So we're checking if X is not equal to Y, which is true. Again, Matlab prefers zeros and ones, so all the trues and falses, can be replaced with zeros and ones. Now we're going to talk about the if-else statement. It builds off that x is greater than y comparison statement. And we start by writing if x is greater than y. And if this statement is true, by the way, anything you see in Matlab that starts with a percent sign, as shown here, this is a comment. Comments are not run by the Matlab program, and they're simply ignored. I've included them in green during this presentation, so you know that that information will not be run by the program. If x is greater than y, if this is true, then we're going to display that x is greater than y. However, let's say the value of y changes to 75. Well, now our statement is false because x is not greater than y, and we're going to want to output that x is in fact not greater than y. The way we'd write this full statement then is as such. We'd have those two display commands, and one of them will be run when the conditional statement is true, and the other will be run in the other scenarios, else, if that conditional statement is false. And we always wrap up these statements with the word end to tell MATLAB that we're done with this statement. In this case, we look, is x greater than y? Right now, yes. 10 is greater than 7, so we run the true case, and we display that x is greater than y. If the value of y is changed to 75 again, then our logic statement here is false. And we jump down and we run the command display that x is not greater than y. That ends the if-else statements. Now we're going to talk briefly about for loops. For loops are useful when you want to execute certain commands n number of times. Maybe you just need to do something 3 times, or 10 times, or 100 times, or 900,000 times. You're going to use a for loop. We have the same variables declared, x equals 10 and y equals 7. And then this is the basic syntax. You write the word for, I equals 1 to 10, and then display x. This is because in this code, all I'm going to do is output the variable of x 10 times. This is an example of how the for loop will do something n times. The 1 colon 10, as shown here, just indicates we're going to go through the values 1 to 10. This will become clear in just a moment. If we ran this code, we're just going to print out the value of x 10 times. On the right, we have our program output. What happens, though, if we change this display to displaying the value of I every loop? The way that these loops run is the value of I is incremented by 1 every loop. So in the first loop, I is equal to 1, okay? We work our way through the loop as such, and we run each command until we get to the end. We're on the second line here, and we need to display I. So we do that, and we get a program output of the value 1, because I, in this loop right now, is equal to 1. We keep moving through all the commands. Once we get to the end, we increment I by 1. So now the value of I is 2 during loop 2. Now we move back through, we run the commands, display I is equal to 2, and we get that program output. Now in the next loop, loop 3, I is equal to 3. We move through, we display I, we get the program output of 3. One more time, I think you guys have this by now. In the fourth loop, I is equal to 4, we display I, and we get 4 out. We keep doing this until 10, because we've specified that I should go from 1 all the way to 10. And then in the 10th loop, we get display I when I is 10, and 10 is our program output. All right. I'm hoping you understood that. We're going to check your understanding with a quick quiz question. I'm going to pull up the Internshala interface here. What is the output of the following loop? And note that we're going to display the value of y every loop. Okay? X is equal to 10 still, y is equal to 7. We're going to display the value of y every loop. What do you think the answer will be? Will it be A, 1, 2, 3, 4, all the way to 10? Will it be B, 7, 7, 7, 7? Or C, 10, 10, 10, all the way to 10? And if you're really doubting me, you can always put answer D as none of the above. Put your answer in the chat of the live stream. I want to see if you guys are understanding this. And the answers are overwhelmingly correct already. I'm very impressed. The answer to this quiz question is going to be B. And that is because y is set to the value of 7, and every loop we're displaying the value of y. The value of y doesn't change each loop. Only the value of I does. So the answer is B. Perfect. We have another quiz question. You guys are doing a great job so far. I have faith in you. What is the output of this loop now? Note that we're displaying the value of y plus I every single loop. X is 10, y is 7. We're displaying the value of y plus I every loop. Put your answer in the description here in the live chat. Is it going to be A, 1, 2, 3, 4, all the way to 10, B, 7, 7, 7, continuing all on to 7, or is it going to be answer C, 8, 9, 10, all the way until 17? Put your answer in the chat. Hope you guys can get this one. All right, I'm seeing Ash said C, Priyanshu said C, Buji said B, Sangmitra said C. The answer for this one, most of you are correct. It's going to be C. Y for every loop is going to be 7, and then I increases from 1 to 10 throughout the different loops. And thus you get 7 plus 1, 7 plus 2, 7 plus 3, which gives you answer C. Very good. Again, the answer was B for the first quiz question. And then when we added that y plus I, the answer was going to be C for this question. Great job. A lot of you answered those correctly. Okay, that ends our basic theory we're going to cover today. Of course, if you want a lot more, there's tons of content in the Internshala training for Matlab. But now we're going to head in and look at 4 different example scripts and projects that hopefully inspire you guys. Here we are in the Matlab IDE. There's a lot going on. I'm going to walk you through the different sections. At the very top, we've got the toolbar. This toolbar can do things like open different files, create new files, save things, set your preferences on your screen to different colors you're using. It's your basic setup for the IDE. IDE, by the way, stands for Integrated Development Environment. This is where you're going to build all of your MATLAB scripts. In the direct center of this screen, right here, this is called the editor. The editor is where you're going to write and edit the scripts that you write. All the code that you put together will be right here. On the left side is the current folder. This is where I keep all of the files that I'm going to be running. On the right side, we'll see in a moment, this is called our workspace, and all the variables that we create when we run a program will show up here in our workspace. And lastly, we have the command window. This is where all the output of our program will be shown. Let's go back to the key principles. I'm going to stop this old script that I was running and then clear all the old variables that were around from that script. I start every piece of code that I write with CLC and clear vars. CLC gets rid of everything in my command window, and clear vars will get rid of all the old workspace variables that existed from a previous script that was run. It's a good way to start fresh every script that you write. You should be familiar with this right here. We did this in the theory section. It's just the if-else statement. We set x to 10 and y to 75, and we know that this statement here will evaluate to false, and thus we run this bit of code, which displays that x is not greater than y. I can run this by clicking the Run button in the Editor tab. As such, it runs actually a whole bunch of code that I've got here. Give me 1 second to just run this specific section. You have to click the Run Section button, not the full run thing, because that runs everything in this script. You click Run Section, and you just get the output for the section that you are in. So here I'm seeing that x is not greater than y. If I change this value here, y is just equal to 7, and we just run this section, we see that x is greater than y because this code was run. A shortcut for using this run section is just Control and Enter, and I'll be doing that for the rest of this code. You should also be familiar with this. This is the third quiz question that we had today, where we display the value of y plus I. I'm going to run this, and you can see in our command window, here's the values 8, 9, 10, all the way to 17. Next, we haven't talked about it, but Matlab is one of the best numerical computing languages. And here's a little bit of an example of calculating different values of z using simple algebra operations. Here we do x squared plus y and assign that to z1. We can take the square root of x, which is just the square root of 10, add 5 to it, and subtract y. And then in here, I'm using the built-in value of pi, multiplying that times y, and then dividing x by 4 and adding that. If we run this bit of code, we'll see the answers to this algebra right here. And this is a great demonstration for how Matlab is used as a very powerful calculator. It's the matrix laboratory. So of course we have to talk about matrices. A matrix just holds an assortment of values together. We could define x1 as 0, x2 as 5, x3 as 7, but it's much easier to put these into one group of values, a matrix called x. And then we can do operations on this value of x. We're all familiar with a simple line equation, y equals mx plus b. I've set the slope of this line to be -1/2, the y-intercept b to be 5, and then I'm going to calculate y equals mx plus b. But here x is this matrix of 3 values. So these 3 values will all get multiplied by m, and then b will be added to those products to get y. So y will end up being 3 values as well. And we can use MATLAB's simple plot command to make a visual of this. We plot this, and here's the equation of our line. Of course, we can do a lot more with this, and we're going to talk about scatter plots in just a second, but these are the very basics of how MATLAB works with matrices and uses them for things like plotting. All right, now let's get into the really cool projects here. I want to show you some scatter plots, and we're not going to worry about the code right now. You'll learn this, you'll understand it more if you get into the programming of MATLAB, but here's some awesome visuals you can make. Here, I've got a scatter plot showing a bunch of values going around in a cylinder. You can see I've got 4 different variables plotted here, x and z, the pressure. I've got the size of each data point changing here. The pressure is being represented by the color of each of these. That's the value of a scatter plot. I think Matlab is one of the easiest languages to make plots in. On the right, we've got this cool topography of sand ripples plot. I'm going to move this around for you, but you can see these plots are just assortments of individual data points. Here I've got each of them. If I can orient above, we can see that we just have these X, Y, and Z positions shown, and they're just individual data points. Nothing too fancy about them. I've got the height shown here on the right, so you know that the blue values are lower and the Y values are higher up in this plot. Again, easy to create, very fun representations of data, and awesome ways to use Matlab. The next script is going to be a game that I actually made in Matlab. It uses the command window. Give me 1 second to break this out. Here's the command window. And then it also uses the plotting to make an animation. I'm just updating this plot over and over throughout the script to show different activities. So here we're going to have 3 tanks that are battling each other. One of them is named Manpreet, one of them is named Phil, and one of them is named Akash. Here you can see that the 3 tanks are ready for battle, and we start off with Manpreet's turn. We have his initial stats. He's at position 5 on the x-axis here. He's oriented to the left. He's got a launch angle, a launch speed, and we can choose now how we want to move these tanks, and our goal is to shoot each other and ultimately destroy the other player's tanks to win the game. Let's move Manpreet to -2, places to the left. We're going to turn him to the right, set his launch angle to 60 degrees, and then put his launch speed to 10 meters per second. Here we see the animation of the missile shooting through the air. He missed that time, very unfortunate. It's my turn now. I'm going to move 1 meter to the right, stay oriented left, set my launch angle to 45 degrees, and then my launch speed to 9. If I shoot, let's see if we make contact. Boom, got him. So Manpreet has been hit there. You can see that his tank now is reduced to 0 lives, and the tank is now black, showing that it has been destroyed. Very fun game I made. These are the type of things that you can do, though, in programming languages. Let your imagination go a little bit. The best way to learn is when you're really motivated about something fun, and this was a great way for me even to learn new features of Matlab that I didn't know before. The last program that I want to show you is a machine learning model. This is very advanced, but don't panic. I need to end the other game. Sorry. Got to end this game here. And then let me redock my... All right, we're back. I'm going to clear the variables again, so we start off fresh here. In a machine learning model, our goal is to learn some function. Here is our raw data. This raw data is basically a line. It's got some noise to it, but we could imagine a trend line going through our data. In machine learning, what we can do is train a model to learn that exact equation of the line. You're going to see a couple graphs in a moment. One of them will be the prediction of this line, and the other one will be the loss. If I run this code will take a bit longer to run because it is a bit of a thicker program. But here you see the model fit on the left. This red line is learning the equation of the line. It started out poor, and now it corrected, and it's almost matching exactly the trend line of the data. On the right is the loss curve. Oh, I'm running it again here. On the right is the loss curve. This loss curve represents how far those individual blue data points are away from the line. So our goal here is to minimize this loss curve. At the very end, we get an output of what the model predicts the line to be, which is very close to the line that the data represents here. Again, very fun application. You can do a lot of different things in MATLAB, from a machine learning model to making fun games to just all your basics. Don't limit yourself to what you can do in programming languages. There's infinite things you can work on, and I hope these have given you some inspiration of what you might be able to do if you dive into this. We're going to head back to the presentation now. And on a final note, I want to talk about careers and jobs that you can have if you learn the language. Keep in mind that MATLAB is a good addition to whatever education that you have. Jobs in the engineering field love having MATLAB programmers. Whether it's electrical or mechanical, industrial, aerospace, civil, there are absolutely applications for MATLAB programming in those fields. Additionally, a lot of researchers will utilize MATLAB, often for visualizing data, for running experiments over time. The biologists, physicists, oceanographers, anyone who's dealing with data is going to be using MATLAB in the research field. Data science is a growing area. You can see that I just made a machine learning model there, but all of the scatter plots we make, that topography model, you can clean data in MATLAB, you can visualize it super easy. Data science is also a fantastic application. And then mathematics. We didn't get into some of the really complex things you can do, but MATLAB has built in some of the best functions for running really complex matrix equations. You can also take derivatives and integrals. You can even do your homework in MATLAB if you want to. The mathematics field really likes MATLAB. That is all from me today. Thank you so much for joining. I'm going to pass it back to Manpreet, and he's going to wrap up today's seminar. Thank you so much for joining.
Hey Phil, you killed my time there. Now I'll have to probably learn MATLAB and take my revenge. But on that note, I wanted to ask you before we open the floor to our audience that as somebody who is eagerly interested in learning more and who is like really new to this topic, what is the right path for me?
Learning programming languages can be very difficult, especially if you've never learned one before. I think the best way to do it is to really sit down with a dedicated class and work your way through it. Internshala has the MATLAB training available on their site, which I actually instruct, and this is the best way to really learn the fundamentals. Sit down, be focused, dedicate yourself to learning those basics, and then go and try the projects like I've just shown you. But you need to take that time. Programming does not come easy. You have to think like a computer thinks a little bit. And the training that I've made on Internshala allows for that development and learning to happen. And we walk you through every single step of the way to build up your programming proficiency. So I highly, highly recommend you check out the Internshala course.
That's right. And for all the keen learners here today, Internshala Training is offering a special 10% discount on our MATLAB training. So you can go on and use the code Practicals10. The link is in the description, so you can go and check it out. And Phil, now I request you to take up a couple of questions from the audience.
Okay, we've got a couple questions here coming in from the audience. Please ask a few more. I'm going to be scrolling through. We've got a question from Arin about my Minecraft server. It's been a while since I've played, so I kind of have a current server that I play on. Thank you for asking, though. Let's see what else is in here. We've got a couple people liking the plots that I showed earlier. Very fun. Yeah, we've got Thulasi asking about, are there any other best ideas for MATLAB other than math homework? Answer to that, of course, is yes. You need to find something that you're interested in, whether that be, making a little robot simulator or making a really cool plot. Or it could be something like, there's a whole field of fractal geometry even that exists. I would say find something you're interested online and then try and just make that. and then motivate yourself through that project. So whether it's a little bit of fractal geometry, making cool plots of information, even just, you mentioned doing your math homework, that's a great place to start. You can do little simulations in Matlab using for loops. Every single loop, you can make something move a little bit further, or you can run an experiment during that. I've used it to simulate dice rolls. So you can ask yourself probability questions about, okay, what's the chance that I roll a 1 and a 6? If I roll 2 dice, how often does that happen? And you can do that and store information from each roll and then create your end stats. There's a lot of different projects out there. If you Google around, just take a look online. We've got a question from Alexa about that hardware was on the programming language slide. Is hardware considered a language? So hardware, basically, the way I had it here, just refers to like the metal, the actual metal that your computer is made out of. But there are languages that get really close to the hardware, binary being one of them, assembly being one of them as well. There's little things that, Intel has proprietary languages that you can program to execute different things at your transistor level, right? You can get really deep, but hardware itself is just physical things, not a language. But there are languages that you can work with. Let's see what else we have. Okay. Ravi Teja asked, what is the difference between MATLAB and Python? Awesome question. The simple answer is that they're extremely simple. And in fact, one that can program in MATLAB can also program in Python and vice versa. The package that Python uses is called NumPy. NumPy is very similar to MATLAB's matrix calculation and things like that. The main difference will be the quickness you can get set up in MATLAB. MATLAB is so much faster, right? You can just download MATLAB tomorrow if you have a license and start running things. In Python, you tend to hit a bit more bumps. You have to get a new integrated developing environment that you want. You have to download specific packages that you need to use. And sometimes that can trip beginners up. But all in all, they interface very similarly. Python has a couple more extensions maybe for, working with the internet. You can do a couple more like, web development stuff and do some more, graphics potentially for the internet. MATLAB has a lot more built-in matrix calculation abilities, things of that nature. But for beginner programmers, they're going to feel very similar because a lot of the concepts that exist in programming languages apply to a lot of things. C++ will even feel similar to MATLAB programmers because C++ is the language that built MATLAB. So there's a lot of similarities between these different languages.
Okay, Phil, we'll just take one more question before we wrap up.
Okay. Deepa has asked, do we need to learn the C language before going for MATLAB? I would say absolutely not. MATLAB is an awesome language to learn as your first language. It's the easiest to learn. It's very simple. The interface has all the features built in for you. You do not need to learn C or C++ or anything before learning MATLAB. MATLAB can and sometimes should be the first language that you learn. Over to you, man.
Great, Phil. So that would be all for today. Thank you everyone for joining us, and thank you so much, Phil, for taking out the time for this session. I hope you all enjoyed the session, and don't forget to like this video and share it with your friends. Do subscribe to our YouTube channel and press the bell icon. We have more such interesting sessions planned out for you, so you can definitely check them out if you press the bell icon. And if you want updates on Telegram, you can follow us on Telegram as well. The link is in the description. So see you guys next time. Bye-bye.
इसकी भी लग गई, कमाल है यार।
भाई, तेरी ग्रेजुएशन कंप्लीट होने वाली है और तू यहाँ बैठ के मटर छील रहा है। कोई ट्रेनिंग कर ले ताकि तेरी नौकरी लग जाए।
करने को तो कुछ भी कर लूं, पर उसके बाद नौकरी कौन देगा? शुरू कहाँ से करूं यार?
इंटर्नशाला ट्रेनिंग से डिजिटल मार्केटिंग, वेब डेवलपमेंट, डेटा साइंस, एनालिटिक्स और पाइथन जैसे बहुत सारे ट्रेनिंग्स हैं जिनसे हो सकती है जॉब पक्की। ट्रेनिंग सेलेक्ट कर और अपना करियर शुरू कर, और वो भी 100% प्लेसमेंट असिस्टेंस के साथ। इंटर्नशाला ट्रेनिंग्स, शुरुआत यहीं से।